In previous videos we've talked about how carbon can bond with other carbon atoms and make giant macromolecules or giant covalent structures such as diamond and in fact also graphite, but there are in fact other substances that can be made or other structures that can be made with carbon, and these are called the fullerenes. Now this is for the higher tier for GCSE Chemistry Unit 2, and I'm just going to go through a couple of possible uses of these structures called fullerenes. Now, one of the most famous ones is probably one of the first to be discovered, and that is called Buckminster fullerene. It's named after a chap called Buckminster Fuller, who I believe was an architect and worked with these kinds of shapes. But what you'll notice is all these blue circles here are carbon atoms, and if you arrange them in a certain way, you can make them to make this almost spherical shape. This is actually has the formula of C60, so it's 60 carbon atoms joined in a particular shape, and it's mainly made of hexagons. So mainly hexagon shapes. Now the first thing you might say is, well, hold on a minute, there's a pentagon right there in the middle. Yes, there is a pentagon. Without these pentagons you wouldn't be able to make this particular shape, but mostly it's made of hexagon arrangements of carbon atoms. So this is one example of a fullerene. It's called Buckminster fullerene and makes that particular shape, and we're going to look at a couple of the uses for it in a moment. Another one is this one here. This is often referred to as a nanotube, and again it's based on a structure of hexagons, and in fact there's no pentagons here, it's all hexagons. So if I was to pull one out over here, okay, you can see it's a hexagonal shape, and it's made of all hexagon shapes wrapped around in this tube structure. Now the key feature about this is that it's very light and can be potentially very strong, and it can be made into quite long tubes, even up to the point of half a meter in length. But the key thing here is it's a structure of carbon that's made using mainly hexagons, and it can be made into these particular shapes, and these particular shapes working at a very tiny molecular level can have various uses, and those uses are as follow. So the first one is that this could possibly, this one here, this Buckminster fullerene molecule could possibly have a use for delivering drugs in the body. The great thing about it is it's like a cage structure, and if you could take a particular molecule of a drug, you can actually lock it inside that particular shape, and that can be used then to deliver this drug to particular kinds of cell in the body. This drug might be quite harmful to cells, but you might want it to destroy or damage certain types of cells like cancer cells, and we only want it to do the damage to the cancer cells, so in order to deliver it to those cells it's caged in this fullerene molecule. So this is a potential use of it as a drug delivery system in the body. Fullerenes can also be used as lubricants and also as catalysts. Because they are very tiny, a small amount of this would have many of these fullerenes in there, and it actually creates quite a large surface area. And some chemical reactions require a surface on which to react, and if you have a large surface area, these can actually increase chemical reactions up very much by a large amount. The other use is more for these nanotubes, and that is for reinforcing materials, e.g. tennis rackets. These are very light, very strong, and in fact somewhere I read they're about up to 50 times stronger than steel, and about one fraction, in fact around about 1/6 of the weight. So you can imagine rackets can be much lighter and much stronger, but it can also be used in other kinds of materials that might require lightness and strength, for example materials that are used on aircraft. Okay, so that's an overview of the fullerenes. They are basically a form of carbon that's based on the hexagonal structure, although we've got a pentagon in here. They can be used and made into a variety of shapes, which can have a whole bunch of different uses, and probably a whole bunch of uses also that haven't been even thought about or discovered yet, but the potential of them is quite huge. So there it is, Chemistry Unit 2, higher material, all about the fullerenes.